Hello, ladies and gentlemen. Welcome to VUX World. This is episode 4, and today we're speaking to Jeff Smith. Jeff works for a company called IPsoft. He's head of the Conversational AI team, and he's working on the conversational AI known as Amelia. Jeff has bags of experience in conversational artificial intelligence. He's even wrote a book on reactive machine learning. Jeff is probably going to be one of the smartest and most technical people I've ever spoken to in my whole life. And we're going to be talking all things conversational AI. So if you're new to the voice design world and the voice world in general, we'll be covering the basics, what it is, how it works, why it's good. If you're a current VUI designer and you're currently working in the voice world, we'll be covering some specifics in terms of how you can implement conversational AI within your designs. And if you're a brand who is looking to explore the world of voice, we'll hope to give you a full understanding of what conversational AI is, how and where it can be used, and what benefits it'll have for you. So, really excited to speak to Jeff. And without further ado, here is Jeff. So Jeff, welcome to the VUX World podcast.
Yeah, thank you very much. Happy to be on here.
Fantastic. Thank you for joining us all the way from New York. So Jeff, would you mind telling us a little bit about yourself and your role at IPsoft?
Sure. So I've been working in the space of data science for over a decade now, and most of that time recently has been spent in AI and machine learning. So I built a couple of different conversational AI products and really working on building the teams and helping to teach others the skills necessary to succeed. And so part of that work also is included some stuff around writing a book around reactive machine learning, which is a concept I developed, but that really came out of my real world experience and applying some a theoretical overlay to some of the true challenges of building machine learning AI systems in the real world. And so these days I spend most of my time either on the job as a manager of a team of data scientists and linguists and software developers trying to build an AI and help them succeed and build their skills and build a more effective technology as a result, or then spending the rest of my time talking with others in the community about particular topics of interest around conversational AI, voice technology, things like that.
Mm-hmm. And I've seen you've done quite a lot of talks and presentations on this kind of stuff as well, in the areas of machine learning as well, over the previous kind of few months, which I've kind of seen, which has been really, really interesting actually. So you're at IPsoft at the moment, working on Amelia.
Mm-hmm. Sure.
So what is Emilia?
So Amelia is a very ambitious approach to a conversational AI. So IPsoft is a digital labor company. So we're trying to create intelligent software that serves the role that a human may have served in the past, to literally work on behalf of our clients. So Amelia is a conversational AI. She also manifests in the form of an avatar, so a computer-generated, a very realistic-looking model that animates and converses with people, and then has a voice-only deployment in some ways as well. So the focus is to really be in any sort of interface that you would want to interact with some form of digital agent that works on behalf of a company, that we want to be there. And so the sorts of jobs that the AI takes on are the sorts of things that people have been trying to find better ways of doing and optimizing for a long time. So these are things like customer service and help desk and these sorts of interactions with between companies and brands and their customers. So Amelia is an incredibly broad and ambitious AI to cover a huge range of industries' needs. And really to be deployed to a very wide range of deployment platforms to be able to take on whatever sorts of challenges that businesses have in dealing with their customers.
Mm-hmm. Cool. So what kind of, that's obviously a huge, hugely complex sort of tool by the sounds of things. What you mentioned that you manage the team that kind of works on that and creates that. So could you explain a little bit about that team and the skill sets that team has to create something like that?
Yeah, so that's probably one of the biggest compensations to doing work in this area, in my opinion, is what the group of people you end up pulling together to do anything really interesting. And so, like in terms of functional skills, the average team, like mine or like previous ones I've been a part of, so there's some core skills around software engineering, so that we need to be able to handle very large amounts of data at scale, very reliably. And so there's a lot of that infrastructure that needs to be built. The expectations for something like say a customer service function or a help desk function is that it's highly available. It's a 24/7. It doesn't matter how many problems people have, that this is a sort of infinite capacity way of addressing things. So there's a lot of traditional back-end software engineering skills necessary to achieve that around stability, reliability, and data handling. But that's not even. But then there's so much more beyond that that needs to, in terms of the team's capabilities. And so some of the rest of those folks on the team need to have skills around data science, and for an application like a conversational AI, you're really talking about people who have expertise in natural language processing. And so some of this may be core machine learning topics, like just being able to train classifiers and evaluate results and implement learning algorithms. But over time, most people who work on this sort of stuff get deeper into the specific techniques we use for language. So for anything that, so while there is a general broad field of machine learning that could apply over all sorts of data sets, like images, like sound, but for language specifically, NLP is a very deep and rich area with a whole bunch of specialist techniques. And so we have people who need to understand the latest in research, implement that within our application, as well as some of those folks actually trend more towards the end of linguistics as well, right? So that we have people who are really academically trained in the structure of language and can reason about domain concepts that need to be expressed in multiple languages. It's probably no surprise that being based in Europe, that when you deploy an intelligent agent to a European customer base, there are expectations about multilinguality. So that an intelligent agent should be able to speak whatever languages the customers speak, and so that there needs to be intelligence that exists behind the scenes, encoded in some sort of way that is not specifically tied to an individual language, but is actually capable of being used across all the languages that the intelligent agent needs to speak. The same way that you as a human, if you say we're an accountant, you would know accounting in English, and then if you also spoke French, you could still have the same conversation about accounting, because that knowledge is itself a domain knowledge. But then you need to be able to express it in both English and French, if in that example. So the AI needs precisely those same capabilities, and folks with expertise within language have a lot to offer a team in terms of being able to capture precisely what are the properties of language we are trying to encode using natural language processing techniques, and the ability to support that across a broad range of domains, contexts, languages, things like that.
Mm-hmm. So sorry, go on.
Sorry, the one I think I left out the folks who actually have to then make the visualization of all this stuff. So there are people who have skills within things like 3D modeling, animation, web front-end engineering, all that stuff, for if you want to go as far as Emilia goes into having a personification that users can actually look at and have a sort of real-world interaction that involves the AI making gestures and having facial expressions and responding empathetically as a human does. That's a whole additional discipline of skills that you need to have as well.
So is that a mixture then of, because you mentioned NLP, that's natural language processing, isn't it? Is that
correct?
Are those skills on? Because I was speaking to somebody else the other day who has a background in playwriting, who has then become a voice user interface designer. Are those the skills you mean in terms of an understanding of language in that way, or are you more referencing the technical side of coping with the complexities of language?
So all of the above typically. And so where I see people who have more of more of a theatrical or writing background, often playing a role, is in user experience sorts of considerations, very often around writing dialogue responses. As we get closer to the issues of natural language understanding, that is comprehending what you as a user have said to the AI, those skill sets tend to be closer towards natural language processing, data science sorts of skill sets. But then you also have people who are trained within like academic linguistics and less around software. And those folks also still have a valuable role to play within really coming up with an implementable, useful way to structure our knowledge about language so that we break down the concepts appropriately and are able to do things like teach multiple languages or learn new domains of knowledge and things like that. So I would slice it at maybe 3 points along the spectrum there, from like NLP experts to linguists to really like user experience designers. And there's space for all sorts of contributions like that. And maybe some people have all of those skills rolled into one, but on a large team, I mean, we're talking about several individuals with kind of different tracks of work, trying to have all this come together to make one valuable, useful experience for the user.
Yeah, fantastic. So you've mentioned in throughout that, in fact, since we started talking, conversational AI and machine learning. So we'll kind of get into the detail of defining what conversational AI is in a second, but could you explain to somebody who is completely alien to this what the difference is between conversational AI and machine learning? Or even AI and machine learning in general, those two things. Are those two completely different, separated things?
Mm-hmm. Yeah, so let's start with AI and machine learning. And so depending on where you look, you're going to find different working definitions. And this isn't a topic entirely without controversy. But the framework that I usually try to use goes something like this. A working definition that most people use of machine learning is that when we say a machine has learned, what we mean is that for some given performance on a task, that with exposure to greater data, the machine is capable of improving its performance on that task. So like a simple example would be a spam classifier. If you got 3 emails and one of them was spam and the spam classifier did not recognize it, then it got a 0% performance. And then we fed it in more data, showed it another 3 emails, and then it was able to get the next spam email correctly classified. We have an objective metric to say it learned using our in that classification example. So machine learning is a suite of techniques that we use to achieve that result, right? So it is all sorts of different ways of modeling how can we teach a machine how to improve its performance on a given task with the use of data. Machine learning can be viewed as a subset of the larger field of artificial intelligence. And so machine learning is the learning aspect of AI. But the best definitions of AI I've seen usually start with a concept of an agent. So an agent, like architecturally, to get a picture of it in your head, is something that has sensors, so it can get data from the outside world. It has actuators, that means it can act on the outside world. It can do things to the outside world, and then inside the box is the rest of the AI. And so there's different levels of complexity there. Like a minimal level of software agent, like a simple bot would be a reflex agent. So every time it saw, the word chicken, it sends back cluck. And so that's a very simple level of agent. Usually what we talk about when we build an artificial intelligence is something that's either an intelligent agent, so that means that it has a knowledge base. There is an actual structure of data that it holds, of things it has learned from past exposure, but that usually is a learning agent on top of the intelligent agent requirement, which means that knowledge base is improved by some sort of cycle. And so that's where machine learning comes in. Machine learning is the actual set of techniques by which an artificial intelligence improves its knowledge about how to perform a given task. but in artificial intelligence itself, typically also has the ability to sense and to actuate. So in my book on reactive machine learning systems, what I describe as a machine learning systems is typically the scope of what we would call a whole artificial intelligence. And so the term has become a little bit fuzzy because very rarely do you only want a machine learning component. You don't just want to learn over data. You actually want to be able to acquire data from the outside world, and you want to be able to act on it. You want to be able to do some sort of whole task, like recommend movies to a user on a streaming site, or to drive a car, or to schedule a meeting, or whatever the case is. It just depends on the task.
Okay, so where does conversational AI fit in there then? What is conversational AI?
Yeah, exactly. So AIs can be tasked to do all sorts of things. And so in the case of conversational AI, what we're really talking about usually is something that takes in language as data and via its sensors and returns out language. And so that, depending on the system we're talking about, that could be textual language, as in the case of like a chat bot, or that could be voice data, right? So that it could be actually spoken language, and so that then that needs to be understood then at its textual meaning, and then it's independent. So there's various phases that may need to be decomposed, and so then whether or not we're talking about our sensors being things that ingest just simple text or audio, and the same for our actuators. They can again send back text, or they can speak. And so, from the perspective of the AI, those sensors and actuators may actually be tied up to another independent system. Like that could go as far as the Slack bot itself, for example, as an interface that would be the joining up the sensors and the actuators there. So conversational AI gives us is all of those people who are working with language, all those different ways that you can set up an AI to handle some form of back and forth over language, typically with another human being.
Okay. So it's conversational AI and machine learning is something that I've the more you look, the more you notice. And obviously over the last kind of few weeks and months, I see things popping up all over the place about machine learning, conversational AI and stuff like that. So let's say, for example, I'm a brand, I'm hearing all these terms, I'm hearing about the developments in technology that enable us to do things like machine learning and natural language processing, which we spoke about, and conversational AI. I'm a brand. Why would conversational AI help my business? In what situations?
Yeah. So there's a lot of ideas kicking around there that people have on how this technology is going to be put to use. And so if we say, let's talk about voice specifically, in the voice applications of conversational AI, there are a certain number of hours a day for each individual person, and depending on which country you live in, based on the assumptions about how much time people spend in cars, where you're inaccessible to a screen. And so that means that for people who are interested in what are some of the tasks that a company could take on for a given consumer during those times in the day in which they're not looking at a screen, they can't rely upon some app that requires them to hit a button. And so some interesting. So of course, if you're driving to and from work, it sounds really useful if your car can literally tell you things without having you to look down at it and allow you to give commands back, like, yes, I will accept that call, or start up this podcast. And so driving is not the only time in which people don't have access to the ability to look down at a screen. And so there's other parts of the day in which it's become apparent that there's all sorts of niceties to having ambient intelligence. So we've gotten used to the idea that facts aren't that rare anymore, that we have access to the world's knowledge a few clicks away, but yet there's something that's still quite magical about having your hands tied up with slicing tomatoes and then needing to figure out some fact about the dish you're cooking and just being able to shout that out and get an answer within seconds of that is an incredibly high quality one, or to connect you up to something that's actually intelligent and that can work through a workflow. So that I don't know if you've tried this before, but you can cook with a voice agent. So like Google Home will find your recipe and will walk you through it. And so these sorts of applications, we're just beginning to see like what are the ways in which a conversational approach will be so much easier. The sort of especially as you notice, I think one of the particularly exciting observations people have had is mobile OS phone install, so mobile app installs have declined greatly, so that people don't generally go out and discover new apps and try out new things, and install rates are terrible. And if you want to launch a new solution, people will typically direct you to mobile web. You're trying to solve this problem for your, say your local museum or something, and how could we best help our customers? And no one's going to tell you write an iOS app. What they're going to tell you is maybe put something on mobile web. And part of that is this sort of like complexity and bloat, and that there's just all these things to manage. And so the web has certain advantages to that. Voice interfaces have continuing that trend, right? In that there's all sorts of advantages to just being able to say, I have this problem. I would like to know, like, what is, what is the, how did this particular stock do today? Like, I want to know, because this is, it's a good way of like checking out my portfolio or something. That there are lots of apps that do that, and they do it really well, and they have nice graphics, and maybe there's a better one this month than the other one. But when you just have a job, it's really nice to just say, I have this problem, to a conversational AI that figures out behind the scenes whether or not it has the capability to accomplish that task, or if it can dispatch off to something else, so that you have this sort of like hierarchy of intelligent agents that allows companies who are trying to solve tasks for users this really very different way of offering a value proposition. Not like, not you need to install our app with our branding to interface with our store in these ways, but rather when you call, we will be there with your need. If you shout out, please reorder me toilet paper, a Google Home will say, okay, in the United States, I can get you that toilet paper from Walmart, from Target, from Walgreens, and if you have some more complex need, then it may, so if you have an informational need, it may dispatch out to a particular Google action that has knowledge about, the stock price example, or, so it maybe handles weather itself, but then there's some specific facts about your local area that are better answered by, a metropolitan skill of some kind, a Google action about New York City particular that knows things about museum opening hours or something. This is a different way to getting to users, and it's a way that has less clutter and cognitive overhead, which represents an opportunity. People are too busy to figure out about your new mobile app on all the things. It's very hard to cut through the noise. But people are starting to learn to just ask AIs for help on the problems that they have. And that's a very different sort of value proposition and different positioning for a brand to take on. It has less shiny visual real estate, but it may be more effective for your consumers, for the people you're actually trying to serve.
Yeah. It's a few good observations in there, actually. I think there's always been a stat, isn't there, where people tend to have something like 9 apps that they use, and that's kind of pretty much it. Whereas obviously with voice, that just expands, doesn't it? You don't need to find an app and to mess around installing it or what have you. Presumably, as I know you need to install Alexa skills and stuff like that, but presumably as the ecosystem grows and develops, the intelligence within there will be smarter, so that you ask and you will get, sort of thing. That would be the ideal sort of situation, wouldn't it? So,
and that is the approach that Google Assistant has taken. They do not use that install-based workflow, and that's what I think is the more future-looking format. I think the idea of skills being installed ad hoc is, I think, creates friction. And so I would say that the Google Assistant approach is certainly an interesting one to think about, right? So that like you don't want to figure out which apps to install on your smart car. Like, if your car can, like you just want it to be able to, like, there's only so many individual computers you want to administer in your life. Usually some of this has to be handled on behalf of users based on inferences about their needs and their and the best way to fulfill them. We just can't all set up the dozens of computers that we now live with, on our wrists, in our pockets, and in the corner in the car. It's too many things.
Yeah, absolutely. Yeah, it's there's something kind of almost sort of refreshing about just being able to speak to something rather than, I've noticed it. I think over the last few weeks, just getting my phone out and texting, and then your watch goes, and then something's on telly, and then you're looking at your monitor on the screen and stuff. There's something a little bit nice about, you almost feel as though you're switched off from everything when you're just talking to something, don't you?
It's strange that like this advanced artificial intelligence based on like fundamental breakthroughs in natural language understanding and microphone technology feels kind of low tech and like you're unplugging. But it's true, right? It's the first exciting platform that hasn't required you to stare into an LED. You know?
Yeah, absolutely, yeah. So does Amelia have a voice interface as well?
Mm-hmm. Right. So we deploy her wherever our customers need her to be deployed, and so we have done deployments that are where you can actually look at her and talk to her, or just when you can speak to her in various formats as well. And I've prior to working on Amelia, I worked on a previous product that had a sort of multimodal interface, but then its primary the intelligent agent, its primary method of interaction was actually to go out and make phone calls on your behalf, which was an interesting application of voice only, because that product was focused on specifically those things which put you as a human in a real-time workflow that took your time, right? Like that you had to look up a phone number, you had to call people, you had to get pieces of information, you had to get tasks accomplished. That was a sort of different approach to using voice. And so I think there's a lot of interesting possibilities out there for where we stick intelligent agents into which interfaces. But I think one of the things I think is most exciting is that the sort of inherent equality of operating through voice, right? That there's when you're able to use like voice and text in particular, that language is this very sort of equal format in which we all have our own voices, we all have our own ability to address each other, and so that there's this open door for new products and new functionality that has this sort of very equal interface, that it is willing to listen to you or talk to you, and I think that's some of the most exciting stuff going on right now, is that people discovering that the world of voice and conversational AI opens up doors that are less about the world of, like, say, video games and arms races around like graphics qualities or something like that, where you have these huge teams producing these massive, or the way that movies and TV similarly work, where there's actually amazing things you can do with particularly intelligent application of small teams towards using some of this really amazing technology to build voice products that seem like something that, how could a handful of people have created that? How is it but that's just where we are technologically. There's this technology is becoming so magically mature that all of this is really productizable. We are now at the point where people can actually build conversational AI products with the same sort of like completely unobstructed access as the early days of mobile.
Yeah, and I think it's probably easier sometimes to build something with fewer people, certainly from a design perspective, because you can focus on the vision as opposed to opening it out to a huge load of people and everyone has an opinion, and before you know where you are, it's hard to keep on top of, isn't it? What was I going to do there? So you were mentioning about the building a conversational AI, and earlier on you were talking about the AI being able to understand what comes through and then give a response. So when it comes to building a conversational AI, and this is something that perhaps the more technical people who are listening to will either be familiar with or would want to know a little bit more about, do you need to define the input and the output? So do you need to define all of the types of phrases and conversations that need to be fed in, and then also predetermine what the responses will be for that.
Right. Yeah. So like, how do we? Yeah.
So, for example, let's say in Amelia's case, let's say Amelia's being used as a, I don't know, let's say that it's a voice assistant that will be able to troubleshoot a problem. I know this might not happen in Amelia's case, but there may be a voice assistant somewhere, for example, that has a conversational AI whereby I could ask it, I'm setting up this iMac, I've got a problem with this, can you fix this situation? So, and even chatbots, I suppose, are a little bit like that, whereby you'll put something in, you'll get something in return. So what you put in terms of the questions that you ask, the way that you phrase things, do you need to, when you're building and constructing this thing, do you need to define all of those phrases that it needs to be able to respond to, as well as all of the answers that you'll get in return?
Yeah. So I think I understand your question, right? So there's like there's maybe a naive, simplistic approach you could use to create a sort of like very crude, basic chatbot, right? That did something like that knew only specific phrases in response to specific questions, right? And that doesn't sound very useful, right? Like if you have to get it precisely right down to the question mark or something, the exact verb tense. There's just not enough time in any organization in the world to write all those possible sentences you could ever have, and to imagine all the possible conversations you could ever have. I know no product that has that shape, right? So we have to do something better. So what we instead do is we decompose the task of understanding natural language into many phases, right? So we're and this is just generally within the field of natural language processing, that we break it apart, and so that we understand, is this a question, and then like we understand, we try to map out, is this a so for example, it really depends on what the problem being solved, how you model the domain of certain things, but like there's all sorts of sub problems with very well established techniques. So for example, like people will talk about co-referencing at times. And so co-referencing occurs when you say that my brother installed this computer. My brother installed this program on the computer in your help desk example there, right? And then later you say, let me ask him what he did. And so him and that follow on needs to be understood, right? So that we need to have a model which is specifically can understand pronouns and the nouns that they refer back to, right? So that your brother in that case. So that we have a whole bunch of those subproblems, and that's how we break it down and to get to the point of understanding things. And a common structure that people will try to get to is an understanding of the intents and the entities. And so the intents are, could be something like, so let me actually switch context to a different conversational AI. At X.AI, built here in New York, we built a conversational AI over email that scheduled meetings. So a meeting set up for me and John next week at 3 p.m. or something like that. Or she would look at your calendar and negotiate with the person you're meeting with, and do all that within natural language. So if we talk about a conversation like that, there could be an intent that's requesting a new meeting. So that is an intent. So set up a meeting with me and John. So after we've gone through those various phases of different models understanding things, we should know what that intent is. We should also know the entities. Me, which is perhaps implicit, or maybe I said it in a sentence. So in that case, and then John, the person I'm meeting with, who now has that we have some concept of what that entity is, that we can identify it, and then we can then make decisions about what to do next. And so those decisions about what to do next can work very differently. The things that we say back than our ways of understanding natural language. So we can have all these intents and entities, but then we have a very arbitrary level of choice in terms of how we respond back. So this is something I talked about at a recent talk, maybe Google Developers Group. So it may not be obvious, but within an AI, your outputs can only the number of output actions is bounded by the number of by the amount of input you can take in. That is, if your sensors can sense, say 4 states, the most you can ever possibly respond is 4 states, right? You can only ever take 4 actions. If you take a 5th action, what that implies is that 5th action is randomly generated, right? It's not based on the data. Right. So we get to those intents and entities, and then we have these choices to make about what level of response we're going to do. Are we going to send a notification? Are we going to then, so that, for example, some of the conversational interactions within the smart speakers, the response to a user input may be to play a video or a song or something like that, or to purchase an item. It may not be to return a sentence. Those sentences when sentences are returned, usually there's a range of different techniques, from full-on scripting, so that that we're just writing it out as predefined dialogue, and so a lot of like the humor and social talk, chit-chatty sorts of functionality. Like if you it works that way, and so Alexa or Google Home just has a database of jokes. So you ask, tell it a joke, and you could ask, tell me a joke in 20 different ways. And the natural language understanding will need to understand the complexity, but then the state space of the response is much smaller, right? It's just, yes, send one joke from the script of jokes. But some responses to users are engineered in different ways. In particular, there's a lot of conversational workflows in which we need to know the current state of the discussion. We maybe need to know people's names and their preferences. So like in the meeting negotiation email example I talked about before, we need to be able to know that currently the meeting is scheduled for Thursday at 3 p.m. and that is the proposal we're trying to get you to confirm, and that you are meeting with Alex, and we need to make sure that his name is included, and that you are meeting at the Bluestone Lane coffee shop. That all those things are very specific. So we need to do some level of natural language generation to assemble up the data that we know about the world. And that's where you start to see slightly more sophisticated implementations of how to form language-based responses to users within conversational AI. So that can be from the level of purely scripted, some amount of templating, to fairly sophisticated, procedurally generated out implementations of being able to form novel sentences based on the data that is actually there at runtime within a given conversation.
Mm-hmm. Okay, so some of the things that I'd kind of along the lines of the conversation. So when a human has a conversation with a human, so we're having this conversation now, I know what you said previously, which then will prompt my next kind of question or the next kind of analogy or whatever, and then you'll respond to that, and then based on something you said earlier on, that might re-jog my memory, and I might then bring back something you said earlier on. And
Yep.
I don't know the complexities of this, and you'll obviously know far more than me. One of the things that I've been reading recently is some of the smart speakers, and I don't know if this is a problem confined to smart speakers or whether or not this is a broader challenge within conversational AI, but some of the things that I've come across has been whereby you mentioned that you can ask a broad range of questions and then you can predefine some of those responses. So then what happens further down the line when a response further down the line is dependent on something that happened earlier on in the conversation? So the context previously, is that something that is possible in conversational AI, or is that something that is that one of the challenges, or is that just confined to the smart speakers at the minute?
Oh, I think it's a very general problem. So I think you called it context there, which is a common name for it. Depending on the context, we might also refer to that as like dialogue state. But yeah, so the problem of context or dialogue state is something that, depending on the product you're building, you may or may not have to address. And so we usually draw this divide. It's what we would call like question answering versus multi-turn dialogues. So question answering is closer to the older field of information retrieval, which really gave us things like search engines. And so you just want to like find out who is the senator of the 12th district. And so it is a single question. It has a single answer. Whether or not the system fulfills that, there's not 20 steps. Most of what you're talking about within conversational AI, those are multi-turn dialogues. And so that presumes that there's some level of dialogue state that's persisted. And so systems have varying levels of complexity in terms of how well they support that. I would say that most of the interactions I've seen on the smart speakers are, at least within the first-party features, are not focused on multi-turn dialogue. They don't expect you to follow up. There's a single back and forth, and that greatly reduces the technical complexity you need to take on within your system. Amelia doesn't work that way, and most AIs that accomplish real work on behalf of humans, which is a small subset but an important subset, have to be in that case. They have to have some concept of a true dialogue state. So when I worked at X.AI on Amy and Andrew, so they schedule meetings over email. That's a negotiation. The whole point of the thing is to accumulate up a sufficient dialogue state so that we know who are the attendees of a meeting with a location and a time, and that everyone has agreed upon. And so that's the whole purpose of the product, is to accumulate out that knowledge and to reference the current state and to work on that task and negotiating it with users. And that's very common, is that I think most of the actually useful applications of conversational AI need to have that. I have some friends at Hugging Face. Hugging Face creates a sort of messaging-based AI friend for teenagers. And so it's all chit-chats, emojis, selfies, very fun stuff. But the point is, it's your friend. It knows things about you. You can refer back to it. You can tell it, like, my dog's name is Fluffy. My boyfriend's name is Charles. And it needs to remember that because it's your friend. And that's the entire purpose of the product. And so you build very different systems to deal with that versus things that are simply trying to deal with a more basic question answering workflow that looks more like traditional information retrieval or search.
There was a really interesting thing I've listened to on another podcast. I think it was the Alexa Devs podcast. I'm not sure if you come across it, but there's a guy called Brian. I think his second name is Romilly. I never know how to pronounce people's second names when they spell it a bit weird. But Brian Romilly. Anyway, he works within the kind of voice space and stuff. One of the things that he was talking about was around exactly what you just mentioned there, around remembering things and these things, remembering, who you are, your preferences and stuff. And he was mentioning something around whereby the way that the AI is kind of heading is that you might have one AI agent, for example, maybe it'll be in your car or something like that. So you might have one in your car, I might have one in my car. It could be the same agent, but it will treat us both differently depending on our personality types and depending on our preferences. So if I'm the kind of person who wants to know the real detail of everything, then it will tell me when I get in the car on my way to work that actually there's a traffic jam further up and it started at 9:30 and it's not going to clear till 10 and etc, etc, etc. It was caused by a lorry that jackknifed. Whereas if you're the kind of person who just wants direct information, they don't care about the detail, it'll just tell you there's a traffic jam, you need to go a different way. So it's really interesting sort of observation, that in terms of the way that one AI might be able to treat people differently based on their either personality or preferences.
Mm-hmm. I think that's very true. I think a very present current day example is the use of sentiment detection and so, for example, Amelia has a subsystem that we call EQ, which is her ability to sense your emotional state and to respond empathetically. And this is actually a surprisingly valuable and early feature to implement in various sorts of conversational products. X.AI had a form of this as well when, for whatever reason, we believed that the agent was in a current state where, there was something difficult about getting the meeting scheduled or something. And so needed to respond to a customer's likely frustration with, oh no, there's, we still don't have this scheduled somehow. That empathy, I think, is actually an underutilized opportunity for building more sophisticated AIs. I think this is something that people don't necessarily start with, but many real-world products end up having to have it. And I think I proposed in a couple of places before. I think that this could be very valuable within the space of voice specifically, and that greater dynamism within the machine learning systems we use to back this technology will give us a greater ability to respond empathetically. So to not be you as a human are just such a tremendously dynamic system. You are constantly assessing my emotional state, and you can respond in this range of different ways based on what you believe my emotional state to be. And that's everything from your tone of voice, the how quickly you speak, the volume, your diction, the pauses you allow between conversation. All of those things, if we make those dynamic within the actuation level, we can take advantage of knowledge that we already have the machine learning techniques to be able to sense about humans, things around stuff. Wow.
That's mind-blowing, that, isn't it? But it is for me anyway, who doesn't sort of work in this field. It's just unbelievable, because that's like, you speak about natural language processing and stuff like that. That's very much, these are the words that we speak and this is how we understand it. But what you're saying there is that it's picking, you didn't even mention language and words there. You're talking about kind of tone, volume, speed. It's all the other variables which you kind of, I don't know, you could quite easily overlook when it comes to creating a voice sort of experience.
Right, and I don't think it's the norm right now. So what I'm talking about is something I believe to be a sort of obviously open opportunity in terms of how we think about user experience. I know some folks at a company called NeuralX, and they're actually trying to do voice-based diagnosis of diseases like Alzheimer's, depression, Parkinson's, the sorts of rich detail that comes out of a voice-based interaction gives us this opportunity to exploit some of these very powerful techniques and really respond, so that if that was just an embedded capability of the technologies you interacted with every day, if your Alexa just said, I think you should really go make a doctor's appointment, or, I've already made you a doctor's appointment because I'm concerned that you may have early onset Alzheimer's, based on what we've been talking about today. It's a very exciting capability, and I think it's one that is very user aligned with user interests, right? It is very user positive, right? That we build these technologies to support human beings. We talk about conversational AI as taking on work for users. There are tools. They exist to serve us, and they should be making our lives better. And so I think thinking about how things like empathy and just taking advantage of the richness of what a human being is, and trying to do everything you can to model that and be as dynamic as that as the motivating example of an actual human being is, leads you to a very different place than thinking in terms of deterministic, simplistic, like pure software techniques. Machine learning has the ability to deal with some of the fuzziness of what it means to be a human being and try to infer what did someone really mean when they use that tone in that sentence. And now we get to take advantage of that. And I think it's really up to us to have the ambition in how we build products and technologies to change that.
Yeah, that's one of the reasons, I suppose, why you mentioned that at the very, very start in terms of having a multidisciplinary team. It'd be fantastic if Amazon and Google did build those kind of capabilities into those things, and Cortana and Bixby and all of the other kind of consumer-facing, big-scale brands who are kind of launching in that kind of space, and who have launched in that sort of space. Yeah, that'd be unreal if Alexa could tell you that it's booked your doctor's appointment based on your voice. That's absolutely staggering, isn't it? So that's a nice kind of, nice view for the future in terms of if that was to kind of transpire. The article you wrote, which was the article that led me to try and approach you to see if we can have this conversation, was all about future opportunities within voice. So in order to get to that kind of future, and there's many other things in there that you've mentioned that would be really, really good, it would be interesting if we could cover some of the points in that article in terms of some of the challenges within conversational AI at the moment. There's a few things in here, we can cover a couple. You might talk about pre-built agents, advanced analytics, self-optimizing dialogues, etc., etc. So could we kind of get into that? I'm conscious of time. I don't want to take up too much more of your time, but we can kind of pick out a few of these. So the advanced analytics thing was quite interesting. So one of the challenges you were talking about is in terms of the analytics that we currently get from these voice sort of platforms being fairly, I suppose, fairly basic in terms of number of app skill downloads, for example, or number of invocations or something like that. And you were talking about that you would like to see more advanced analytics. Can you speak to that a little bit and give some examples of the kind of analytics that you think that would be more useful?
Yeah. So I mean, I think where we're at right now is that sort of analytics telemetry around voice, particularly like voice skills deployed to consumer platforms, is pretty similar to the stuff that you would expect around website analytics from like a sort of digital marketing or so just trying to so it's kind of a crude view of the world in comparison to what we're often trying to achieve in a conversation. And so inside a company where there's a lot of investment on building out a conversational AI, the sorts of questions we want to ask ourselves are quite fine-grained. I mean, we're trying to understand what it is about particular conversations that is making them successful or unsuccessful in some fairly domain-specific formulation of what success or failure means, right? So, like one company, so X.AI schedules meetings, and so its definition of success is that the meeting got scheduled. And then there's also all sorts of ways that you would slice that down, so that for anything like that where there's a task, there's usually an implicit assumption that people want to have less back and forth, less conversational steps before they get to a successful outcome. And so that and the ways of visualizing and analyzing this data are kind of hairy. There's this thing called a Sankey plot, which gives you an idea of the amount of a given, say, conversations routing through a particular dialogue tree or something like that. So like a particular, if the conversation takes a particular direction and then it wraps up pretty shortly, that lots of people that works for, that indicates some part of our conversational AI that's working really well. If by example, the alternative is some looks like a snaky spaghetti line that goes out very far to the right, which means that a small number of people were in this weird conversational path that kept going back and forth between the user and the AI. And that can be inferred to mean some form of difficulty or unhappiness, right? And so, and then once you identify any of those things, then my next question is, okay, now why? Why did that occur? What's successful about this successful one? What is unsuccessful about the other one? And you end up having to read a lot of language. And for many of these things, if you're successful, you're talking about reading data at scale. So this really is something that should ultimately fall within the functionality of the software systems we use to manage the technology that actually implements a conversational intelligence agent. I want to know what my AI is talking about and succeeding at accomplishing for the user and why, and ideally have as many of those decisions made internal to the system in real time, like self-optimizing, the same way we would do for, I built machine learning systems for ad tech. And so, advertisements are shown to you because they were successful with other users based on real-time data. So, if you see the blue ad versus the yellow ad, if people clicked on the yellow ad more, then that one automatically wins. And at this point in time, humans don't make those decisions. We don't need to figure out how to build software that can be used to encode our human intuition and do this in real time and at rapid scale. And that's ultimately where we need to get to, through understanding dialogue in real time.
Mm-hmm. That's really interesting. Now, the other thing you were talking about was security. And there's a wicked clip in that article, which I'm gonna play it, right? But okay. I want to know. I don't know if it's going to come through for you or not. It'll definitely play and it'll definitely record, but I don't know if it's going to come through for you. But I'll try it. It's the Donald Trump thing.
Yep.
So I'll play this, and then you can speak a little bit about your kind of concerns and the challenges with security in voice stuff. All right. So let's give this a go.
The United States is considering, in addition to other options, stopping all trade with any country doing business with North Korea.
Okay, that was Donald Trump. well, it wasn't Donald Trump, it was Lyrebird who have created a representation of Donald Trump. Did that work over your end or not?
I didn't hear it, but
Okay.
I hope you heard it on the recording.
Yes, it will be on the recording, definitely. But you know what it is anyway, because you found it and you put it in your article. So that is a synthetic or a generated voice of Donald Trump, which sounds freakishly like the real Donald Trump, and presumably that something like that would be good enough to fool for maybe a banking phone-based authentication, voice-based authentication, or something like that. And I think that's one of the things you were talking about in the article in terms of security limitations or challenges. Do you want to speak a little bit about those security concerns?
Right. So all that wonderful stuff about how we'd like to just talk to machines and not have to touch them and to scroll through these things, and it comes with a cost, right? Is that the more functionality we embed within a voice interface, the more reliant we are upon the presumption that just being able to speak to it is a safe interaction, right? And so if, for example, you wanted to be able to do things like purchase items via your voice, that implies that you ultimately have access to money with just your voice. And so I'm not sure if this feature is supported on Alexa yet, but within the Google Home platforms, it recognizes multiple voices. And so it has a model for each speaker who has an account. And so I can ask, what's my schedule look like today? And my wife can ask what her schedule looks like today. And it distinguishes between them. And so if we use voice as an authentication mechanism, we're kind of at an unfortunate point in technology because it's now a very real world to clone human voices at a level that's nearly indistinguishable and will rapidly be truly indistinguishable. Especially so if we were having this phone call. If we were having this conversation over like a traditional telephone line, which has a lower rate of audio than most VoIP or video streaming solutions, basically we're already at the point where a synthetic voice and a human voice aren't distinguishable, like at a slightly lower quality. And so this is rapidly advancing. This is such a productive area of research. And so if we have business processes, if we have governmental processes, if we have things that are today being accomplished by two people just talking about it, maybe just by voice, we're now already in an age where you can't distinguish, and so voice as a security mechanism is a pretty poor one. And then the same is, and there's other weird and kind of scary attack vectors that come out of using voice assistants. And so there was a really interesting paper that came out, I want to say this week, maybe last week, about the ability to silently inject voice commands into a stream of audio. And so this is, you could be talking to a smart speaker without a human being able to hear you.
High frequencies, sort of like...
I don't even know that it's actually using the frequency so much. It's actually an artifact of reverse engineering how automated speech recognizers, the component of the stack that takes sound data and turns it into text. It's actually through a pretty sophisticated re-engineering of that. It's not merely like outside of the human range of hearing. And so these sorts of attack vectors exist anytime we rely upon machine learning models to make decisions, right? And so if we say that if we build a lot of powerful technology that is controlled by human voices, then we need to be prepared for a world in which human voices can be injected into places, the same as other forms of attack vectors, right? So that there's also a field of this where within the space of computer vision, right, where people are demonstrating how trivial it is to disrupt image recognition things, so that whether it's to use a picture of your face to unlock your phone, which was true for the early versions of Google's and Samsung's facial recognition technology. But then also this affects what the world's going to be like when all of the cars on the street are being driven by machine learning algorithms and not by human beings. Whether they recognize things based on the fact that they can be disrupted by really small variations within the images that they've been trained to recognize. And so people will do things like small black and white stickers can completely fool machine learning algorithm to say that a watermelon is a gorilla or something like that. This is all of the exciting possibilities of the technology we're developing right now. They come with risks and costs, and these are some of the challenges we're going to be undertaking if we really want to embrace this new method of interacting with machines. We have to come up with solutions for problems that look quite a bit different than the way that we've interacted with technology before.
Mm-hmm. Wow. Yeah. Although there is, I wouldn't particularly enjoy it if someone cloned my voice and managed to hack into my bank over the phone. But you had mentioned that you did work on an automated AI which makes outbound calls, which that would actually come in handy if you could replicate your voice to then make your own phone calls with your own voice.
Yeah. And so there's definitely a very benign usage of some of these things. And so there are people who are pursuing building artificial intelligence that are meant to really represent their users as a sort of representation of you in other contexts. The first application of this, I think, is really like celebrity sort of thing. So that a celebrity is a way of like producing a product to sell to its fans. Will have these sort of 3D avatars with their voice in them. But if you want to have a sort of infinite, unbounded conversation with an AI representation of some famous person, you don't want to you can't actually have all of their speech pre-recorded. In fact, what you need is a machine learning model of their speech. And so, and that can create, I think, fun experiences. That's certainly going to create like neat toys and things like that, and video game experiences. If you're playing some historical time travel adventure, and then John F. Kennedy is the character, and he sounds precisely like John F. Kennedy because he's a machine model produced to be exactly equivalent. And so that you have this, you can have these sorts of experiences that are that weren't possible before and are interesting. We get to make these choices as the humans in charge of what technology we're going to use and to build, and we get to choose whether to deploy it for creative and fun and worthwhile goals versus sort of nefarious techniques like stealing your bank account.
Yeah, cool. Finally, then, lastly, and then I'll let you go. You've obviously got far more important things, I imagine, to work on. You mentioned a few tools in a few of your talks. One was Spark, and the other one was where has it gone? Scala. If someone there may be people listening to this who are on the design side, who are more focused on how they can create a voice experience using conversational AI. There may be people also who are quite on the technical side who maybe aren't involved in machine learning and the development side of AI at the moment. So for those kind of people, what would you recommend for getting started in machine learning or AI?
Sure. I think there's probably a couple of different options. The dominant stack, I would say, within like machine learning and AI right now usually involves programming in Python and then using libraries like scikit-learn to implement traditional machine learning algorithms, things like pandas and NumPy and SciPy to work with data at a lower level. And then TensorFlow from Google is another library that's very powerful for building deep learning neural network sorts of techniques for modeling. And so that's sophisticated stuff that's become very accessible, and the documentation and they support is really good. Some of my past work on Scala, which is a functional programming language, and Spark, which is a data processing framework that also contains a machine learning library, is really about doing all this work at enormous scale in very real world production scenarios. And so it's not necessarily where I would recommend someone start merely for educational purposes, but it can often be a good basis to, if you're part of an organization that already has large scale, that has a large customer base, and you're trying to do this in an environment that it's just going to touch a lot of people from day one, that's going to have a lot of data flowing through it, then tools like programming languages like Scala and frameworks like Spark really allow you to reach that scale out on day one with confidence that this is battle tested and deployed throughout all sorts of applications within and outside of AI, machine learning contexts.
Fantastic. So where could people, what I'll do is I'll get the link to your book for those people who are probably a bit more technically advanced than the beginners. I'll put all the links to your article and things like that in the show notes. But where could people contact you and find out more about you?
Sure. You can find me at reactivemachinelearning.com. That brings together a lot of the resources we've discussed on this call. And you can find me on Twitter at Jeff K. Smith Jr. And I'm always happy to help people with topics like how do I get started in machine learning, where to start. And I try to have good answers to those sorts of things and point people to good resources. Talking with a wide and vibrant community is definitely a big part of the reward of working within this sector specifically. Just tons of smart people, and it's great to talk to people.
Fantastic. Wicked. Well, thank you for joining us, Jeff. That is probably the most interesting conversation I've probably ever had. I've learned so much in that. Well, I don't even know how long we've been talking, to be honest. Time has just kind of got away with me. But that is from beforehand, and there'll be many other people listening to this who've are complete novices when it comes to things like conversational AI and machine learning. And just to get to the opportunity to speak to someone with your kind of experience and skill set to speak a little bit about it and define some of these terms and to give us some real life examples and context and, you know, the tools and everything has just been absolutely fantastic. So thank you very, very much for setting the time aside to speak to us.
Thank you very much for having me. I really appreciate it. It's been an interesting talk, and I hope some of this is interesting to your listeners.
Cool. Thank you very much. Mind blown. That was an immense conversation. Thank you so much for Jeff for joining us. That was unreal. Considering I had no prior knowledge beforehand, there'll be people listening to this with no prior knowledge beforehand of conversational AI or machine learning. That was super, super interesting. Be sure to check out the article I was talking about the opportunities in voice. I'll link it below. I'll link to all Jeff's stuff. If you're a technical kind of person and you're already familiar with machine learning, etc., you can pick up his book. I'll link to his book. And yeah, thank you, Jeff. And thank you all for listening as well. So until next time, see you later.